All right, let's take a look at some of these other exam review problems. So for number 12 and 13, they're both very similar. In fact, we're doing a transformation. Don't forget high school RV. Okay, horizontal shift, stretch or compress, reflection, vertical shift. Write an equation for a function whose graph fits the given description. Starting with our parent function of x squared, it is shifted 4 units left. Okay, so if I start with that, that would be x plus 4 squared. Stretched horizontally by a factor of 2. So horizontal, that's with the x, and then remember it's the reverse. If it is actually stretched, we want to use the 1 over that factor. So then that will be 1/2 will go with the x inside the parentheses, plus 4 and then squared, and now it's moved up 3 units. So that's going to be g of x equals 1/2 x plus 4 quantity squared plus 3. And that will be my final answer for that. 13. Write an equation for a function whose graph fits the given description. All right, now it's square root of x. It is reflected in the x-axis. So for that one, right there, reflection in the x-axis means you change the sign of the answer so the negative goes on the outside. Stretch vertically by a factor of 4. Okay, with the vertical, that means it goes outside the operation, and so that is going to be -4 square root of x, and then shifted 8 units up, so I get g of x equals -4 square root of x plus 8. Okay, that is going to be our second one, 13. 14. Find the inverse of f of x. List the domain and range of the function and inverse. Okay, to find an inverse, first of all, we take the f of x out and we make it a y. So it's the same as y equals 3x minus 2 over x minus 4. To find the inverse, you flip. You make every y an x and every x a y. So now it becomes x equals 3y minus 2 over y minus 4. We now need to solve for y. All right, we got 2 y's here. We got a y in the denominator. Easiest way to do this, or what we have to do, is to get rid of this denominator. Multiply both sides by y minus 4. So that will give me x times y minus 4 equals. Now on this side, those cancel, and you're left with 3y minus 2. All right, distribute your x. We got 2 terms of the y. We want to get those both on the same side, everything else on the other. I am going to subtract 3y to take it over here, and I'm going to add 4x to take it over there. That gives me xy minus 3y equals positive 4x minus 2. This is where we factor out the y. And now I divide by x minus 3. So now that gives me my inverse function of 4x minus 2 over x minus 3. All right, I got to find the domain and range of both of those. So let me go back up here f of x is my original function, 3x minus 2 over x minus 4. F inverse of x, what was that? 4x minus 2 over x minus 3. All right, now let's do the domain of the function. Let me see, I want to organize this. Range of the function, domain of the inverse, and range of the inverse. All right, the domain of the function, basically you're looking at what will make the denominator 0. We don't have any square roots. We don't have any logs. So the only thing that'll be undefined is 4. So our domain is negative infinity to 4 union 4 to infinity. The domain of the inverse, what will make the inverse undefined will be 3. So I go down here and I make negative infinity to 3 union 3 to infinity. Now to get the ranges, this is where we use that property that the domain of the function will have this, in the range of the inverse will be the same, and the range of the function in the domain of the inverse will be the same. So once I find the domains, I use those to get the ranges. Okay, using that property I just stated. So the range of the function will be negative infinity to 3 union 3 to infinity. Okay, so those two match up, and then the domain of the function and the range of the inverse will match up. All right, so that is number 14. 15. Now your grid did not come out as nice on your paper, I don't think. But when we're graphing a function, remember, we don't even know the equation, but for an inverse, if xy is on the function, that means that the point yx is on the inverse. So you just flip those values. So I need to find somewhere I can see where they hit at nice points, and I'm going to use those and flip those. So that is 0, negative 3, which means negative 3, 0 will be a point. 1, negative 2, negative 2, 1. 2, 0, 0, 2, and that is 3, 4. So I go to 4, 3, make a point. Now here it's going to be asymptotic to that line y equals 4. So when you do the inverse, it becomes a vertical, negative 4. This is not going to go past negative 4. Like I can take a look at that point, which is like negative 2, negative 3.75. So go to negative 3.75 and negative 2. And I need to connect those the best I can. So that is going to just keep going down. And then don't forget to put arrows on it. It is a reflection across the line y equals x. Let me see here. Which this is not perfectly square. So I want to make sure. Oh, there we go. We're okay. That line right there, that will be the line, that reflection. Okay, so that's how you do that problem. Piecewise function. I'm going to cut this into two pieces. One where it's greater than or equal to, one where it's less than 2. Okay, for this one here, f of x equals x minus 2. Only for numbers 2 and bigger So start with 2, you plug that in, 2 minus 2 is 0. We plug in 3, we get back 1. We plug in 4, we get back 2. You need to be able to recognize that x minus 2 is linear. It's going to be a straight line. So we start at 2, 0, 3, 1, 4, 2. It is going to be a straight line. And it will start at 2 and go up. Make sure you put an arrow on it. So you get that one there. The other one, negative x squared plus 6. It's a parabola or part of a parabola, and it opens down. Now it says x is less than 2. Even though it says less than 2, you still plug in 2. You always plug in that breakpoint, and then we put an open dot there. We put a little open dot next to it. And now when we plug that in, I get 2 squared is 4. Negative 4 plus 6 is 2. So you get the point. Whoop, let me do an open dot. At 2, 2, you get an open dot. Now that is the only open dot. Everything else is closed dots, regular dots. So I'm going to plug in 1, 0, negative 1. You need to plug in enough numbers to make sure you get your parabola shape. So when I plug in 1, what do I get back? 5. When I plug in 0, I get 6. I get 5 again for negative 1, and I get 2 for negative 2. So a dot there, dot there, dot there. And now it will be a parabola. Oh, not a very well drawn one. That goes through those points. And make sure you put an arrow on it. So there's your parabola, there's your linear. You got an open circle at 2, 2. These should both come to that same point. There should not be a gap. Don't start at 1. Make sure you start at the break point, which is 2, even if it doesn't equal that. All right, so that is 16. 17, use synthetic division to find the quotient and remainder when the first polynomial is divided by the second. All right, all we're doing is using synthetic division. If it is x plus 2, remember we put negative 2 to the side in the box. Our coefficients are 2, negative 3, negative 1, and 2. And then remember, you add vertically. 2 plus 0 is 2. Whatever number you get in this bottom row, you multiply by the number in the box. We get negative 4. So we add, and I get negative 7. Negative 7 times negative 2 is 14. 13 times negative 2 is negative 26. And that last number is our remainder. This answer down here is always 1 degree less than the original. So it becomes 2x squared minus 7x plus 13 plus negative 24 over x plus 2. So there's our answer for 17. All right, 18. It just says list all possible roots. This is where we do the b over a's. So our a's are the numbers that divide into the coefficient of the highest degree, plus or minus 1, plus or minus 3. Our b's are the numbers that divide into the constant, which would be 1, 2, 3, and 6. And so your possible roots are always in the form b over a. And so you take every b divided by 1, which would be plus or minus 1, 2, plus or minus 3, plus or minus 6. Now take each one of these divided by the 3. So that gives me 1/3. And then that gives me 2/3. 3 divided by 3 is 1, which we already have. 6 divided by 3 is 2, which we already have. Okay. It does not ask what are the zeros. It just says list the possible roots. That is all you have got to do. Okay, that is it. Done. Now 19 says find all zeros, real and complex, of this function. All right, since we are allowed to use your graphing calculator, we don't want to go through a whole process of guess and check. So we can graph this and then see where it hits the x-axis. So I'm going to go to y equals. Well, that actually looks like what we got in there. I got x to the 4th minus 4x cubed minus 5x squared plus 38x minus 30. So that is the graph I want. We hit graph. We see where it hits the x-axis. Now, I don't get a great feel for how the whole equation looks. You don't need it. You can change the window if you want, but I just need to know where the zero is. If you want to double check, you can go to the table, and it says when I plug in -3, I get a 0, and when I plug in 1, I get a 0. So those are my two zeros that I can tell at this point. So x equals -3, x equals 1. So we have got to use synthetic division to find anything else that potentially could be out there, because we have to have it 4 zeros counting multiplicity and complex roots. So I go -3, and then I got 1, -4, -5, 38, -30. And that gives me 1, -3. Now these better, as long as there's a root, you have got to end up with a 0 at the end. -7, +21, 16, -48, -10, and then -10 times -3 is +30. So I get a 0. So now I use this depressed polynomial, the answer on the bottom, and now I do synthetic division with 1. And you got to use the answer that we just got. And then same thing, I get 1, -6 here, 10, +10, 0. So this is what we got. Since -3 is a root, x plus 3 is a factor. Since 1 is a root, x minus 1 is a factor. And we are left with x squared minus 6x plus 10. Since there was no other places that hit the x-axis, that means that they're going to be complex roots, and I'm going to use the quadratic root formula with x squared minus 6x plus 10. And we want to see where that equals 0. So I get x equals -b, which is 6, plus or minus -6 squared minus 4 times 1 times 10 over 2 times 1, which is 2. I get 6 plus or minus 36 minus 40 is -4 over 2, which becomes 6 plus or minus 2i divided by 2. Now 2 goes into both of those, so I will end up with 3 plus or minus I. All right, it says find all zeros. So our zeros are the original -3, the 1, the 3 plus I, and the 3 minus I. So that is 19. All right, 20. Draw a graph that has 3 real zeros, 2 positive zeros with multiplicity of 2 each, a negative 0 with a multiplicity of 3, and a negative leading coefficient. Okay, so we got 3 real zeros, 2 positive, 1 negative. That just means it hits the x-axis, 1 on the negative side and twice on the positive side. Let's take a look at the overall degree. The 2 positive zeros have a multiplicity of 2 each. That has to do with their degree, so that means they're both degree 2, which means I have a degree 4. Negative multiplicity, negative 0 with a multiplicity of 3. So that means I have a 7th degree, and since it has a leading coefficient that is negative, it will go from positive to negative. And a multiplicity of 3 is the negative one. I come to that first. It means it's going to bend or squiggle through there. So I need to start positive. And if you can't draw these, you need to at least make sure you point it out to me, because you got to show that it goes through there on a bend. And now it's going to bounce because it's degree 2 or multiplicity of 2 at both of those x's. So it should look something like this. If you want to write bend, or write squiggle there, bounces should be obvious. So that's what your number 20 should look like. Okay, 21. Find the domain of the variable in the equations. Write your answer in interval notation. All right, so for g of x equals square root of 2x plus 3 over x minus 4, you cannot take the square root of a negative number, and you cannot divide by 0. So we got two things going on here, which means 2x plus 3 has got to be greater than or equal to 0, and x cannot equal positive 4. Okay, so we got to throw out the 4. Well, just solving this, I get 2x is greater than or equal to negative 3. X is greater than or equal to negative 3 halves. If you want to think number line, greater than or equal to negative 3 halves would start here, but here's the problem. It cannot equal 4, so it's got to skip over 4 and then resume. So it's got to look like that. So our domain in interval notation will be a bracket, negative 3 halves, to 4 union 4 to infinity. Okay, so it starts at negative 3 halves, it skips over 4, goes 4 to infinity. All right, log base 4 of 10 minus x. I don't need to do anything with this. I just need to realize that I cannot take the log of 0. You're not allowed to take the log of 0 or a negative number. So that just means 10 minus 6x is greater than 0. And now I need to solve for that. I'm going to add 6x, divide by 6, and that reduces to 5/3. It's greater than x. And now I'm just going to flip that around. Make sure that's x is less than 5/3. If you think about that on the graph, it will go from negative infinity to positive 5/3, not including 5/3, which means you have a parentheses. Okay. All right, so there's 12 through 21. I'm going to stop this, and then I will do the rest in another video.